first of all, thank you everybody for taking time today to join us for our webinar. These are interesting times. I know we're all busy, and actually some of us have a little more free time. So we're happy to get on a call here to talk through this with you. So good morning, good afternoon, and good evening wherever you are. What we're going to talk about today is really CockroachDB and how it fits with Kubernetes. I joined this company, about a year and a half ago or so because of what I saw from having a true database that was cloud native. But we'll get into that in a minute. We'll show you guys a demo and everything too. Before we get started though, a little bit of housekeeping. I'll just make sure, if you do have questions along the way, I'll try to grab them and float them into Chris. I'll typically paraphrase things just to make sure that it, maybe collapsing a couple of questions into one and whatnot throughout the way. But if you have questions, please do dump them into the QA panel. We will distribute a recording of the webinar after this event to everybody who is registered and everybody who's attended. So don't worry about that. We'll get that over to you. And then there is a survey at the end of this. If you could please give us a quick feedback in that survey. Super, super helpful. We always endeavor to make these things better and better. And so that feedback is really critical to us. So thank you in advance for that. So today I am Jim Walker. I am in product marketing here at Cockroach Labs. Been with the company, I guess, a year and a half or so. And I am joined by my friend, Chris Casano. Want to say hey, Chris? Awesome.
Hey folks, good to meet everyone. Chris Casanos. I'm part of Cockroach Labs in the sales engineering group. I've been with Cockroach for about 5-6 months now.
Yep, and so and a master of Kubernetes and in Zoom meetings, I guess. So, all right, Chris, let's just jump into this. So, I'm going to do a little bit of slide work just up front, just to set the stage on a couple of things. But just before I jumped into this, if you're in the Kubernetes world, you probably are familiar with my person who's pretty well respected in that community. Somebody I've been lucky enough to at least interact with for the past couple of years. Kelsey Hightower, and kind of really being a luminary in the Kubernetes space. This is just last week. This was March 16th. He was tweeting out. We actually had a promoted tweet that's talking about this webinar actually, and Kelsey actually echoed some of the things that we think about. And he and I have had conversations about CockroachDB years ago in terms of how it actually fits into this whole cloud native world. And Cockroach Database really does meet Kubernetes. It is kind of a very similar architecture, and that's what we want to show you today. It was architected for the same world. I mean, if you think about, the internals of Google and Borg and what they have as their backend, if Borg is equal to Kubernetes and Spanner kind of works with Borg, well, I think Cockroach Database and what we're doing here at CockroachDB really does match and mirror the architecture that people are finding in Kubernetes. And a true distributed system and this kind of basically a general approach in terms of distributed systems of what we're doing here. And so it's just a really, really good fit for Kubernetes. We couldn't have been happier that Kelsey tweeted this out. So thanks, Kelsey, wherever you are. I know he's on a podcast tomorrow with the New Stack with another really, really smart guy, Ben Sigelman from Lightstep. If you're all looking for something to do tomorrow, that's a really good one. So a little kudos out to those two and to the New Stack. So, such great pieces of media here. So Kubernetes, just background, awesome. Over the past couple of years, we've seen kind of the emergence of Kubernetes. We've really seen it establish itself as kind of the orchestration layer of these modern workloads as people start to move towards microservices and really, shifting and taking advantage of the cloud. And so Kubernetes is really just an orchestration platform. It allows you to basically scale up and down. Use etcd, it's the brain of Kubernetes, scale the amount of services you want up and down, and it's going to ensure that your applications are always on, right? But I think one of the things that holds back Kubernetes a little bit is when we start to think about, multi-region clusters, when we get, these broad geo-distributed configurations, it's still a little bit difficult to actually deal with these things. I think there's a couple of companies who are trying to actually deal with this some of the stuff. How do we fix some of the cross-plane issues? There's actually a project called Cross-Plane by my friends at Upbound who are doing some interesting things. How do we actually control these things and create how can we have a federated set of Kubernetes clusters that span multiple regions? I think that's one of the things that's a little bit different and difficult, definitely from the Kubernetes point of view, as we go out and start to roll these things in kind of global scale. Now, can we get global clusters? Yeah, I think it's the networking, the securities, the storage, some of these things get really, really challenging. Now, CockroachDB, however, was architected for this truly distributed environment, like truly being a geo-distributed global application. We don't think about, regional instances of CockroachDB. We think about nodes and how they participate in a larger scale across, global implementations, right? And so, we can actually implement a database across, multiple different clouds. It can be inside Kubernetes, outside Kubernetes. And as long as those nodes within this database, typically we'll do 3 to 4 nodes in a region, as long as they're able to communicate with each other, really ultimately any one of them is an endpoint and an access point to the rest of the database, which is, truly kind of remarkable, kind of astonishing in that, the database itself and the binary in which we actually implement and we will deploy in a pod, and Chris will show you that in a little bit, that binary is the same across the board, no matter where you're at. We don't have different types of nodes. It is one single atomic unit, and it packages everything within that database, the storage, the execution, the security, all this administration and integration, it is one binary. And that allows us to be this kind of shared nothing, single atomic unit, the same thing everywhere. Every node looks the same, and it matches really with the architecture of Kubernetes and the whole infrastructure of pods. The beauty of Cockroach Database is that, well, the name is basically, it's kind of hard to kill. It's hard to kind of lose this data, right? If we lose a node, we're still going to have this, we're going to have another node that's going to have that data, and I'll show that a little bit. But ultimately, this unique distributed architecture is what allows us to fit very well within this cloud-native world, this shared nothing world, the single atomic unit of the application itself. And so there's lots of things that we can do. We, again, inherently multi-cloud. We can actually I could spin up a node right here on this laptop. Chris could spin up one in his machine. You're up in, I think, New York somewhere, Chris. I'm down here in North Carolina. We could have another node in a cloud somewhere. And as long as we have a TLS connection between all of us, it is one single database, apparently, to the end user, who's ever accessing it through any one of the nodes. Every node is a single consistent gateway to the rest of the database, which is kind of cool, right? Everything's in that point. We rely heavily on Raft within the database itself to actually accomplish a lot of this. MVCC and Raft are two of the core pieces of technology that allow us to get consistency and then replication of data. Every table in Cockroach is actually broken down into a KV store. We actually use KV at the storage layer. And it's just one big monolithic key value space. We're able to break those things down into ranges, and each range, which is a 64 megabit chunk of data across each table, is actually written in triplicate across multiple different nodes in the cluster. And so we always have 3 copies of the data. It's configurable. You can have 5, whatever you want. But we're always able to have this consistent access to this data. You're always going to have access to it. And so these RAF groups, which are these replicas, is really kind of the trick behind how we're actually able to sustain always on availability and be this resilient database. It is kind of that point. There's also kind of a leaseholder within the concept of RAF. So for a piece of data, a row of data, a range of data, if you will, there's always going to be one node that's actually the master for all of that. So that actually we will be able to provide consistent transactions. We'll be able to actually control how commands are actually written against the replica set. So a little bit in the weeds, but I think important to kind of set up a couple different things, and I'll let Chris get into the demo. Number one, when we place replicas within nodes within this database, we actually write it in triplicate. We're going to actually place data based on what kind of failure domains you want to survive. You want to survive a disk failure, a single machine, rack data center, even a regional failure. We can configure on a table by table basis how this is actually going to happen. Sometimes you actually want some data to actually, be able to survive a region, but the other rows, it doesn't matter if a region goes out, it's okay, right? And so you can actually do it it's a simple alter table. We can actually do it in real time. We could change things too. But the database itself is actually going to actually distribute the data across multiple nodes. So if I lose a node, I'm still going to have access to that, right? And so we're going to put the middle range onto those nodes. The third range is going to actually be distributed. So we've actually distributed on diversity here, and we're equalizing from a storage layer, how the data gets actually distributed. We can actually also distribute and place data based on load. So say we have a hot range of data, these records, Lady, Lula, Muddy, and Petey. that range is it's a hot range. It's really being accessed a lot. We can actually isolate that into nodes that have less utilization so that we can actually increase performance of the overall database when we write that data. And then a unique capability of what we can do also, because we are geo-partitioned or global and geo-distributed, is we can actually do something called geo-partitioning, where we can tie data to a location. So, and that's at the row level on a table, all configurable in the database itself. So based on a particular column of data, let's just say US records live in, in these two nodes, and German records live over in Germany, whatever, we can actually start to geo-partition. It's a key requirement when you do a distributed database, because having data close to users is actually pretty important. Latencies are a problem when you have distributed data. I can't, like I always joke with our internal, engineering team, I don't think we're actually fighting anybody in benchmarks. I think we actually fight the speed of light. And that's our true kind of, bellwether for how we perform. And so geo-partition is a key piece of basically configuring the database, both for, how you're going to survive failure, but how you're actually going to provide the right latency and the right access capability to the user. All said, this is a geo-distributed cluster. This can all run on Kubernetes, right? We can actually rebalance data. I add a new node, it's smart enough to actually just balance data, right? And so no more manual sharding. The database actually just consumes that and spreads data out. If I lose a node, I can actually know that's going to happen. One of my replicas is missing, create a new version of that data and creep it up. So this ability to scale, this ability to survive failure, this ability to be able to basically run in multiple different units, it's this atomic unit running on multiple different pods in multiple different places, is really kind of the key things that allow us to actually, work extremely well with Kubernetes from an architecture point of view. Now, there's technology in Kubernetes that allow us to actually do this. The storage layer and how do we attach persistent volume from the storage class within each pod. We actually rely on stateful sets pretty heavily, so we're pretty happy when that technology got graduated and released way back, it was a year and a half ago or whatever. A key piece of what we're doing here. Operators is interesting, and Chris, I'll talk to you about operators as you get into it. But from the core kind of like capabilities of managing the database, scale, resilience, we don't need operators for those basic things. We do need operators for a couple other things. We're building some things for some more advanced features. But enough of Jim talking about PowerPoint or slides. Sorry, I was 15 minutes, Chris. I think I'm 4 minutes over. So let's get into the demo. Let's show some command line. Let's show some database, Chris.
Sure, sounds good. So let me just share my screen here. Thanks again, Jim, for that great presentation. All right, how am I looking?
Looking good, buddy.
All right, great. Let me just make this full screen so everyone can see it. All right, let me just walk. I only have one slide, and then we'll get right into the tech. So I have a quick demonstration today. So we're going to show how we can run CockroachDB on EKS, and we'll use StatefulSets to do this. What you're going to see is that we're going to do this with a custom CA or custom certificate authority. But after that, we'll go and deploy a stateful set, which will deploy CockroachDB on Amazon EKS. We'll also connect a really simple Flask app. So this is just a small Python application. It's basically a to-do application. There's nothing really fancy about it, but it just shows you how you can connect to the database. And then we'll do some resilience testing. You can do this all yourself if you want. I've published the GitHub link up here at the top, so you can see all of my assets there. The checklist, if you want to go about doing this at a high level, I'm not going to go through all these details, but how this works is make sure you have an Amazon account, install the client tools. You'll need things like the EKS CTL. If you don't want to do the secure deployment, you can use Helm. There's a couple other things there that I have it all listed in my GitHub repo. You'll deploy the EKS cluster, create a custom CA, add those certs into your EKS cluster. As another option, you can add another container registry. So in my example here, I connected to Docker Hub to pull down my Flask app. And then from there, we deploy Cockroach, deploy a secure SQL client so you can query the database and connect your app. It's pretty much that's straightforward. All right, so let's run through the demo. Actually, let me stay in the browser. Let's start with the end state in mind. So I'm going to show you what we're going to deploy towards the end. This is already deployed, but then I'm going to go through the process of how we set this all up. So right now I have this really, like I said, really unfancy, Flask application. It's basically a to-do application. And the to-dos that are here is basically all the objectives you want me to go through today. How to create the custom CA, deploy Cockroach as a stateful set, and so forth. So yeah, we can add another item here. So let's say, we'll call this the homeschooling of CockroachDB using, and we don't need that. We'll just create a simple entry here. All right, so we'll add that to the list. So you can see that going through the application. We can confirm that's actually happening on the database as well. So if I go into my screen here, Jim, does this look okay as far as size?
Yeah, I can see it. I mean, a little bit bigger might be
okay.
A little better, Chris, but.
Yeah, hopefully that's a little bit better.
Yep.
All right, so let's just go to the database, and you can see there I have, the 4 to-dos I had before, and then the one I just added just now. All right, all part of the database. All right, so what we're going to do is we're actually going to kill this thing. You're probably saying, wow, we just started the demo, we're going to kill the demo. And yeah, that's what we're going to do. And actually, before I do that, let me just show you what's running in my EKS environment. Actually, let's get a better picture. Yeah, I'll give you everything. Okay, so we have a pod of our application that's running here. We have a 3-node Flask application that's running. We have a 3-node Cockroach database that you can see here. We have our secure client shell. So if we want to do database queries, mind you, each one of these pods here are all the same binary. So this is what Jim was talking about before. We have a really simple deployment model for Kubernetes. You don't have to think about masters and workers and separate clients, all one binary. And you just pick how you want to deploy it through using stateful sets or the other config items that you have with Kubernetes. On top of the pods, we have services. So we have a DNS service. We have a load balancer. That's all here as well. That's all part of the stateful set deployment. Here's our stateful set. You can see that we have 3 of the 3 pods running right here. And then here's all the secrets, or what we call the client and node certificates. So those are added into Kubernetes as well. All right, so what I'm going to do is I'm going to remove all this stuff. All right, so all this stuff is going to get removed. As it's going to get removed, I'm going to walk you through how a stateful set works. All right, again, if you come to GitHub and you go into the Cockroach database repo, navigate your way to the path that you see here in the Kubernetes section. We have a YAML file or configuration file for how you can apply a stateful set, and it's pretty detailed. As well as we have this all in our documentation as well. So if you go search through our docs for setting up Kubernetes as an orchestrated deployment, we have this here as far as how you can do this with EKS, with GKE, and you can use similar steps for other flavors of Kubernetes. But the idea here is if you want to create a custom CA within EKS, here's basically the steps you have to do before you deploy the stateful set. So first thing you want to do is you want to create these basically these cert directories that you see here. You'll create a certificate for the certificate authority itself. You'll create another one for the root user, and then you can add that that root certificate right into Kubernetes, and that gets placed as a secret. The same thing goes for the search that you need for the nodes. That's done right here. Again, you'll create that as a secret that then goes into Kubernetes. And then the last step is just being able to deploy your stateful set with all the security infrastructure that's in place. Okay, so that's how it works. I can go through the rest of the YAML file, but it's a lot of stuff to go through. At the end of the day, what you're seeing in here is, I'll just show you real quick, is that there's a section where we create the stateful set. We always want 3 replicas. There's some more details here about what image to use, what ports to use, and so forth. The other big one that you're going to see in place is persistent volumes. So what's great about stateful sets, especially for databases, is that if you think about Kubernetes historically, has worked really well with stateless apps, right? So I can just put any pod up there, you know, it gets killed, it comes back up. I don't have to worry about its state. But with databases, state's important, right? And so how Cockroach utilizes stateful sets is that anytime we're going to go create a pod, we want to make sure that when that pod, you know, if that pod gets killed, it comes back up, it has the same network identity and it has the same, mapping for its storage. That way you can keep its state even as failures happen on the pod side. So that's what we're going to see today. Let's go back to our screen. Yep, we can see everything got deleted. And now what we're going to do is I'm going to have I call this my self-driving demo. So I just have a script that I'm going to run here. It's going to walk you through the process of how things get set up. So I'll kick this off. And you can see that it's going to go create the stateful set. This is really just one command. It's just kubectl create -f and then the stateful set YAML file. That's all getting loaded into Kubernetes right now. And you can see.
Hey Chris, I think that's another. I think that's another version of kubectl, kubectl. That's a new one.
Kubectl.
But yeah. Anyway.
I've just been calling it K. From now on, I've just been calling it K, but you can call it whatever you want. Kubectl, kube control, whatever flavor you like. Yeah, Kubernetes has lots of flavors. So as you can see, the stateful set was created. This is kind of the same details I was showing you before. Things are still popping up and so forth, but we can keep it going. So next thing I'll do is I open the admin UI so you can see what Cockroach looks like. This will just take a second. All right, here's my cluster. All right, we have the 3-node cluster. You see the nodes here. If we go and look at the metrics, you can see that the cluster just started, and we're getting some metrics coming through. We can look at the databases. You can see that actually, even though I blew this the whole environment away, all the pods, the stateful set, and so forth, I actually still have my to-dos database. And that's because we have those persistent volume claims within Kubernetes that allows us to reattach that storage to those pods. So I can go in and, all of my data is still there, even when I, blow away the stateful set. So that's all there and good. And let's go back to, the next thing. The next thing we want to do is deploy our Flask app. And maybe I'll just walk you through what that looks like real quick. So if I come through to my editor right here, so I basically have an application. I have a Docker file that basically goes ahead and creates this into, into a Dockerized app. All I really did here is in the configuration is to be able to put the connection string to the database. So that's what you're seeing here. This is SQL Alchemy using this connection string. You can see I have my my certificate here. I have the user that I have in the database that I needed to connect to. I have the node address where it needs to connect to. And again, this is the load balancer address that I'm connecting to. I'm not connecting to an individual node. I'm going through the load balancer. And that's pretty much it. So let's go to the app. We'll start up the app now. This will just take a second as well. All right, just refresh that. All right, there's my app. And I can go ahead and update these things. And then again, that's going to create the queries on the database. Why don't we do this? Let's do the resilience test. And we're gonna kill a node. All right, we're gonna kill actually both a application node and a database node. All right, so I'll leave this here. And then the next step of my self-driving demo here is actually to go ahead and do a kubectl or kube control or kube whatever. It's just
kubectl.
Kubectl. This is going to be a kubectl kill. So it's just going to eliminate 2 of those nodes. And as that's happening, you can see my Cockroach number 2 node is getting deleted, as well as the application. There'll be another one for the application as well. I'll go ahead and create this entry. You can see that the entry still goes through. And even if we come over onto the cluster, I'll refresh this screen, you'll see that there's actually a node that went down, right? But we're still able to fulfill transactions even when some of these nodes are down. what you're going to see happen from here is that Cockroach is going to, patiently realize, hey, I have a node that's down. Kubernetes is going to know that the pod is down, and eventually that pod will get spun back up. You'll see that the database is actually under replicated right now, because we always, like Jim mentioned, we always like to replicate things in threes. Since we only have 2 nodes that were alive, we wanted to make sure the data is replicated across. As you can see, that node came back, so now we have 3 nodes all up as well. If I refresh, another minute or so, you'll see that we won't be under replicated anymore. We'll have the data available across all the different nodes, which we have now.
Hey, Chris.
Yeah.
Sorry, I dropped for about a minute and a half. Welcome to COVID craziness here, but I'm back. One of the questions we had was, what happens if you delete the PVC for a single node?
Oh, for a single node. So yeah. So what will happen? What should happen is that we'll create a new persistent volume claim. So you're basically starting. This almost works the same like you're working on a bare metal or in a cloud environment. You have to mount new storage. In this case, you would mount EVS storage to that node. It's a new node. It's almost like decommissioning a node and Cockroach and then adding a new one.
Go on. Sorry.
Okay.
No, I was going to say, but you wouldn't have lost any data or any access to that data because the resilient nature of the database itself, because we still have 2 copies of that data, right? I mean,
that's correct.
Yeah, you still have 2 nodes that are still live and good.
Absolutely, yeah. So you still have 2 nodes that are live and good. That 3rd node that you're adding again is going to have a new mounted storage, and then the database, Cockroach database, will start filling that node up with replicating the data from the other 2 nodes.
Yeah. Hey, Chris, at some point, are you scaling up this cluster in this demo today, or we're going to do another one?
I don't have that today, but I think you could do that through just going through the one easy way to go do that is through the stateful set itself. There's a replication factor here of
3.
Of 3, and then I can go change that to 5, and it would add more pods to the environment.
Okay, so you could add more pods, add more instances of CockroachDB, and then somebody's asking like, hey, I'd like to scale back to, say I scaled up to 9 and then I scale back to 8. What does that look like? And the database is actually just going to take care of all of that scaling up and scaling down and moving the data around, right?
Yeah,
you're never going to lose anything.
You basically just tell Kubernetes how many pods you want up for that stateful set, and then Kubernetes will handle it for you, and then Cockroach handles itself very gracefully. Whatever you're telling Kubernetes to do, like Cockroach just manages within those constraints.
Yeah, so you're just changing,
which is rather nice.
Yeah, exactly. Like it's going to elegantly take care of it in Kubernetes scaling up, but then our own instance of etcd is basically handling our side of it as well, right? So
correct. Cool. We'll start moving the leaseholders that you talked about before, and off we go.
Great.
Awesome. It's transparent to you.
Just real quickly while we're talking, I know a couple people have asked in the QA and the chat, like, hey, can I get these scripts? Where is the YAML? It's in Chris's Git repo. I'm gonna grab that and dump it into the chat right now. There it is. Yeah. So that's
right here.
And I'll dump that in the chat for everybody too. So go on, Chris. Sorry.
Okay. Yeah, I think that's I think we did. So if we think about it, we did our resilience test. We showed the custom CA. We showed how to deploy the app, the Flask app. So I think we did everything here in the demo. So maybe it was good that we go to questions or any Q&A.
Yeah. Let me just go through some questions here, Chris. What is the average time taken to bring a node up or down or up for CockroachDB, Chris?
It's pretty quick. If you bring up a brand new node, it's a few seconds.
Yeah. And then this is actually asked a couple of times. Do you know how big the binary is for CockroachDB, and then how big the container would be for it?
That's a great question.
It's 159. This was a trick question. I knew the answer, buddy.
No, you got me.
Yeah, Peter Mattis answered for us in the background. It's 159 megabytes, and I don't know what that is for the container. Do you know what else would be in the container, Chris, as well as our binary?
You can have some pretty small containers. depends what you want to put in there. Some folks want to put other overhead type of pieces for monitoring and so forth, or other things you might want to do in a container. But you know, the thin containers are just that, they're thin.
Okay, yeah. And then where were you running this, Chris? Was this on your machine, or were you using, you know, Amazon, GCP, or was this all local today?
Oh, this is all in EKS. Right now I'm just doing port forwarding that you see here. So that's why it all looks like it's local, but all this is in EKS. So if I go back here, ES control, get, what is it? Cluster. Yeah, so here's my cluster right here.
Yep. Cool. And then, so this is an interesting question. I'm going to paraphrase it a little bit, Chris.
Sure.
This was an anonymous. It was asked anonymously. You know, what happens if you delete a majority of the copies for a range? I think it's an interesting question, and I think it comes back to basically how do you architect your implementation for survival of what you want to survive, right? And so I'm kind of leading the question, but how would you answer that, Chris?
Yeah, so it starts there, right? It starts with how much you want to survive, right? Anytime we start architecting applications, there's two things we want to keep in mind. What do you want to survive? And what does your performance need to be? We will look at those two things to architect you correctly, to make sure we're, you know, properly distributed across regions, properly distributed across the availability zones, properly distributed across the amount of nodes. So yeah, the last thing you want to do is lose quorum within ranges. We always want to make sure you have a sense of quorum. So when we talk about survivability, that's what we talk about. It's like how much do you want to survive? Is it, you know, you're okay to lose a region plus 2 nodes or 2 regions? Like, we'll go through all those details so that we can maintain quorum within the database.
Or maybe you have 2 copies in one region and 1 copy of the data in a third, so you can actually survive the regional failure. Sometimes you want all 3 copies in the same AZ or the same region, right? I mean, it just depends on what you want to actually accomplish, correct?
Correct. Yeah, you have some trade-off between, you know, survivability and performance. So that's why we architect you that way, is to think about what's really important to you, and then we'll figure out what's the best arrangement for your setup.
Yeah, and it's really the likelihood of basically losing a majority of the data. What happens when we say, you know, say we're running 3 nodes in a single region, we lose basically, you know, a majority of the nodes, Chris? I mean, are we losing data, or what? How do you come back from that?
Yeah, so there's a couple of different ways to think about this. So one is, just like any database, you should always do backups, right? We have backups as part of, you know, the database. You could do incremental backups as well. So, you know, all enterprises want that. We have that as part of the database. Even when you get into multi-region setups, we have backups across multiple regions as well.
Right.
So it's a great feature. Make sure you're always using it, especially if you're going to do, you know, anything with your database. It's always good to have backups. And what was I going to go? I was going to go somewhere else.
Well, I just, you know, and it's distributed backup and restore as well, which is kind of interesting.
Right.
Like if you have like geo distributed clusters and you're, you know, doing geo partitioning for some sort of like compliance issue and privacy issue, even the backup and restore would actually maintain the compliance with the distribution as well, right? So here's a go on, Chris.
Go ahead.
Yeah. So here's an interesting. So if it's all one binary, how does the master-slave election happen? And I think this is kind of like, you know, how do we deal with leaseholders and gossip and all that, right?
Yep. So that all goes back to Raft when you think about it, right? So instead of doing, you know, Raft or consensus at a database level, we're really doing this at a range level, right? So that's why we don't have to have this whole master-slave concept, because we're breaking that down into much smaller parts within the database to allow that to happen. And then each of those Raft groups are, you know, they have their own election process as far as who's going to be the leaseholder, who's going to be that reader and writer for that range. So instead of doing this at a master level at the database, it's actually happening at a much lower level in the database.
Right. Right.
Great question.
And it's actually at the row level and within each of the replica sets, right? And so, yeah, I think it's funny. We get in a lot of conversations about, you know, active passive setups, right? You know, there's not a person who hasn't, you know, built or architected the database over the last, you know, 20 years has been dealing with active passive, right? And so how do we deal with that, Chris? Right? Because I think it's one of the unique characteristics of this. Well, related to this question, right?
Yeah, it's almost it's almost like a foreign concept to us because we're always in an active state. So we spend less time thinking about those types of setups of how we have things as active passive, because the database is always active and active, even if you're across multiple regions. So there's less thinking about how to even construct doing that because the database just handles it for you.
Yep. I'm going to pick this one off actually. Is there a white paper that we could refer to? Actually, we are actually publishing a paper called The Architecture of a Distributed Database. There's a webinar that actually happened. If you go to our website, you can actually find that webinar. Alternatively, in the next week or so, the engineering team here actually published a database published a paper to Sigmod about CockroachDB. So keep your eyes open for that as well. We'll release that pretty soon here. I know Rebecca and the team actually just finished up on that, but man, that gets into some really, really deep details of this database. If you really want to get under the covers and see how this thing works, that white paper will get into gory detail. But there are different levels. There's a webinar with me, the marketing guy, talking through the architecture. Yeah, it's not so bad, but it's not near the deep engineering side of it. It's somewhere between this and that. So let's see here, Chris. I'm just looking through the questions, buddy. 1 second. So the data can be distributed across regions down to a set of records within a table. Can you just describe how geo partitioning works, Chris?
Yeah, sure. So you have a bunch of different options with geo partitioning. So let's just peel back what that is. That allows you to actually partition data across different regions. So if I have one table, let's just call it a customer table, and I have a way of where a column, let's just say within that table, let's just call that region. What I could do is, based on the values of that column, I can partition the data across different regions. So let's just say for that column, I have an east, central, and west value for that column. I could say I want all customers that are in east to be in the eastern region, all customers in central be in the central region, all customers in west be in the western region. I might want to do that for maybe my identity management or identity access management application, so that users that are authenticating in central or that live in central can actually hit Cockroach in the central region, as opposed to going out to the west or the east. So that's what's nice about geo partitioning, is that you can bring the data closer to your users or where the usage is or resides. It's great for those types of use cases. It's great for GDPR or data locality scenarios where you have to have data reside in a particular region. It's a pretty fantastic feature that the database supports.
Yeah, but this is something you need to think about up front though too, right? I mean, you need to think through like, okay, is there a country code? Is there, maybe it's confidentiality level or something, like we can tag a node as anything, but you've got to think through this when you're actually deploying the database, because it ultimately ends up being the key in the key value pair that actually ends up in the storage layer, right? And so I think up until, we have a release coming out here, 20.1, where we're actually able to change the primary key with online schema change. So in production, we can actually change those values and have everything start to distribute all around, which I think is really, truly awesome, right? Like online schema changes. I think Postgres had this a little bit, about 1.5 years ago or so. And then we're just adding it as native capability, but in a distributed world. And you're going to start seeing data be redistributed across an entire planet. So let me connect that actually, Chris, with the next question. Can you talk about Postgres compatibility and how we talk about that and what our approach is?
Yeah, so this was a terrific decision from the founders early on to support the Postgres wire protocol. And that's what Cockroach supports. So anything that you're running in Postgres, for the most part, a majority of those statements will work within Cockroach. There are some caveats to it. There's some features within Postgres that we don't have on the Cockroach side, things like stored procedures and so forth. But for majority of the SQL syntax that you have, a lot of times it will just run within Cockroach. What's also great about that too is that there's a huge driver community in the Postgres community, and you could just use those Postgres drivers to connect to Cockroach. We don't have a specific driver that you have to use or conform to. which gives us a lot of ubiquity as far as being able to connect multiple different applications and programming languages, right into the database.
Yep. Yep. And so wire compatible, it should work with lots of applications, but anytime you're refactoring the database, I think it would be irresponsible to ever say a migration is easy, right?
That's correct.
I think that's, yeah, exactly.
Migrations definitely take planning.
Oh yeah. So, and working with Flyway, working with Liquidbase, some of the more popular migration tools, we're pushing forward with a lot of that stuff to make this work just the way that you all work today. Two more questions. One of them was, do you have any performance benchmarks? I would encourage you to go to cockroachlabs.com, look in our documentation and search for performance. We have a web page or a page within our docs that talks through how we actually think about performance. All of our most recent benchmarks are there. I think some of the repos, if you wanted to run TPCC against us as well, you can actually go out there and, yeah, there you go, Chris, thank you. You can actually go down and download how we actually run it. We are all about basically publishing as much as we possibly can about how we go about benchmarking, and using standard benchmarks is a real critical component of what I do, the way that we think about this as well. Again, I think our battle is with the speed of light and less with the distributed stuff that's around us. All very important. But let me just get one more question, Chris, and it actually had to do a little bit with Postgres. And yeah, go on, please.
One more thing on the benchmarks. So
yeah,
this comes up a bunch, and we actually have workloads that are built right into the database.
That's
so
right.
You could just do a sniff test. You don't have to go think about, how I'm gonna reharness everything and run it on Cockroach. We have a bunch of them built right into the database. So if you go and look at Cockroach workload, there's ones for TPCC, YCSB. There's a couple other ones that we have in there. They're great ways of just doing a quick smoke test to make sure things are running okay, and you can look at how things are performing. So, we want to want to make it easy for you.
Yeah, try different configurations. As you start to get comfortable with alter table and how those things work, and start running workloads against it, right? And see for yourself. So, exactly. And that's all built into the binary, right, Chris?
Correct. So on the binary, nothing additional you have to do there.
Yeah. So one last question. This has to do with the developer experience. What does it look like for the developer? What does it look like for the client that's doing this? Our operations failing, or retry logic. In a consistent database, especially in a distributed world. It's if I have a transaction coming from Sydney, one from New York, who wins, and how to, there's this consistency thing. And there are transactions that may conflict when you do this, but it's important that, we're going to implement serializable isolation so that we actually protect you from those sort of things. What's the experience for the developer when they're dealing with a distributed database?
Yeah, so it's a great question, Jim. So and I'm glad you mentioned serializable isolation. That's really a big takeaway from all this. And developers sometimes have to get used to that because they've been so used to not having that strict isolation level, and they have to build that into their applications.
Right.
So there's less logic that you now have to put in your applications, and you can rely on our database more to do that isolation level for you. So changing the mindset a little bit, I think, has been something that developers have to come around and think about maybe re-architecting some of their applications as how they talk to the database. But the experience is pretty straightforward. Like I said, you can use those Postgres drivers that are out there that you can use for Go and Python and Java. It's very easy to connect to the database. We have a lot of first-class support and care for some of the ORMs that are out there that developers like to use. And we're seeing more and more of that as developers come on to Cockroach. They want to use the ORMs that are out there to make their application development really, really fast and seamless.
Yeah, Django ORM, Juke, Hibernate, Go ORM, Pony. Oh gosh, we published a whole bunch of them.
So many, yeah.
Yeah, but hey, man, listen, you got to surround queries with retry logic anyway. I don't know, man. Maybe I'm
yes. Yeah.
I don't know. I like good comments and I like good code. I don't know. That's a separate story. So, all right. Well, thanks, Chris. That was really great. And far well and beyond just the demo. Again, if you want to go to the next slide, Chris. Thank you, buddy.
Yep.
And I'm sorry. I put your repo on the last slide, but there's a couple more things. we have a Kubernetes bootcamp, which if you go to cockroachlabs.com/Kubernetes-bootcamp, goes through kind of stateful sets, goes through a couple different webinars. There's some papers we've written around, how we actually work really well. There is actually a video podcast. It's kind of cool. Cockroach Cloud runs on Kubernetes. And so, our team of SREs has learned a whole bunch in terms of how to run a complex distributed database across, multi-regions and in a single region. In our experience, there is kind of interesting as well. I know our team spoke at Cloud Native Rejects in front of the last KubeCon. We were going to go to Amsterdam this weekend, but like everybody else, we're home, so that would have been this weekend, but that's okay. We're going to take part in Cloud Native Rejects, the virtual side, the virtual version of that as well. And so I would highly encourage people to go check that out too. It should be a good conference. And then there's a great blog post I was talking about earlier, the 4 properties of a cloud native database. And that's, if you're going to build a distributed system, being truly a distributed system in that, shared nothing, single binary, this is the lowest atomic unit is the database itself. I would go check that out too. So one more slide, Chris. Thank you, Chris, for everything today. I love working with you, buddy. And, it was a great demo.
Likewise, Jim.
Yeah. And everybody, please do complete the survey. It's really helpful for us. Go and download the stuff that Chris shared. This is the GitHub repo right here. And then just a reminder, we will send the replay link to everybody shortly. So this will be available. So with that, thank you for taking your time today. Maybe people do have a little extra time in this world of chaos right now. I find myself busier than ever. But thank you, everybody, and thank you, Chris, for joining me today.
Yeah, thank you, everybody, for joining.
All right, everybody, be safe, wash your hands, and take care of yourselves and your families. Bye now.